strategy on how to solve word problems. Okay, just start working on the warm-up. Welcome back, guys. Once you finish the warm-up, just type the answer on the chat, then we'll discuss about it. So just take the first 3 minutes. Norma, what do you mean infinity sign replacing 3? So you mean from negative infinity up to infinity, or many solution? So you have to specify your solution. Okay, good. Okay. So I think you are referring to this interval. Excellent, Deborah. Yeah, that Norma, that means all real numbers. All real numbers. So sometimes you say many solutions or all real numbers. Yes. So this symbol means all real numbers. Yeah, so that sometimes it's it replaces many solutions. So when we say many solutions, it's just infinite many solutions or all real numbers. So these 3 can be used interchangeably. Yes. Okay, guys, it's been 3 minutes. Anyone with different answer, please write on the chat. So Deborah says it is many solution. Norma also says many solution. Technically, she says all real number from negative infinity up to infinity. Anyone with different answer? Okay, excellent, you two. Now let's go over the problem. So what you have to do is just distribute the 3. So you have 3x, 3 times negative 3 is negative 9, plus 6 equals 3x minus 3. Then combine these 2 will give you a negative 3. So 3x minus 3 equals 3x minus 3, which is basically you are comparing the same expression. It's true. You can stop here also, but let's combine the values. So I will take away 3x from both sides. So when you do that, this will cancel out, and you have negative 3 equals negative 3, which is a true statement. That means you have many solutions. Okay. So by many solutions, we mean all real numbers. Okay. Or from negative infinity up to infinity. So this 3 means the same thing. Okay. All real numbers, or from negative infinity, smallest number, to positive infinity, the biggest possible number, all real numbers. Okay, very good. So let's move to today's topic. Now, there are 3 objectives in the first topic, which is 4.3, simple inequalities. We will talk about the concept of inequalities. What are inequalities? What are the symbols for inequalities? And we'll see some properties of inequalities. And finally, we solve simple linear inequalities. Okay. So inequalities compared to different expressions. So with that, let's see some of the vocabularies we are going to use. So we see what is less than, what is greater than, what is less than or equal to, what is greater than or equal to. In the next slide. Okay, here we go. So the vocabulary first, what is inequality? Inequality is a mathematical statement that one algebraic expression is greater than or less than another algebraic expression. So in short, inequality compares two algebraic expression which are not equal. Sometimes can be equal. So if you want to include equals, we say greater than or equal to or less than or equal to. So we compare two algebraic expressions which are not exactly equal. So when you compare two algebraic expressions which are equal, that means equation. When you compare two algebraic expressions which are not equal, it is called inequality. So they are not equal. So that's basically what inequality means. So we use different symbols to compare two different numbers or expressions. So the first one is called less than. So this is the symbol for less than. So left hand, for middle school and young kid, we use hand. So if you see this one, the left hand side is less than, and that's the symbol. It represents the less than. That, for example, 3 is less than 10. So when we compare the number 3 and 10, we know 3 is less than 10. That's basically what that means on the right hand side. The example, 3 less than 10. Greater than, the right hand. So greater than. The symbol is greater than, and if we see 15 is greater than negative 3. So 15 is greater than negative 3. Yes. So when you have two numbers, you can compare them by using this inequalities. Okay. Now, one simple trick. If you forget which symbol to use, I know you guys know what is less than, what is greater than, you know the symbols, but for some reason, if you forget the symbol, always the symbol open to the bigger number. The open side would be always to the bigger number. You see here, the open side is to the 10. The open side is to 15. But the symbols are different. One is less than, the other one is greater than. But always remember, the symbol will open towards the bigger number. Okay, so just if it helps. Sometimes you may forget the symbol. If you forget, I know you guys know this symbol. It's not something new for you guys, but if you forget the symbol, it's always open towards the biggest number. Now next we'll see a greater than or equal to or less than or equal to. Sometimes we can include the number and we make it less than or equal to. So the difference between less than or equal to and less than is the less than or equal to will include the equal sign, equality. For example, it says negative 11 is less than or equal to negative 11. So we can't say negative 11 is less than negative 11, but when you include less than or equal to, that makes the statement true. So negative 11 is less than or equal to negative 11. So negative 11 is less than 2. That's also true. So you can see the example clearly. The less than or equal to includes negative 11 also. Next one is greater than or equal to. Greater than or equal to. So negative 3 is greater than or equal to negative 7. So on the number line, when you go from left to right, it is going greater than. So it's just increasing. Left, right. Numbers are increasing. So let me show you one thing. So on the right hand side, for positive numbers, let's say you have x here, y here. I don't know what is x, what is y, but x is less than y on the number line if it is positive. But for negative x here, y here, when you have x here, y here, the same applies, but the magnitude of the number is different. So this is also less than. So this can be negative 10, this can be negative 2. So negative 10 is less than 2. Here you have 2 and 10. 2 is less than 10. It's always from left to right, it is increasing. From right to left, it is decreasing. Okay? So you can just try to remember the numbers. So sometimes students get confused with negative numbers. So 3 here, negative 3 is greater than negative 7. Even if the magnitude negative 3, the absolute value of negative 3 is 3, but it is still greater than negative 7. That's what I'm trying to say. So negative numbers is just flip. Negative 3 is greater than or equal to negative 7. Because it is to the right of negative 7. Because negative 3 is to the right of negative 7. Okay, now let's go to the next slide and see properties of so we'll see properties of inequalities. If you have any question, please type on the chat. Now, when you see these properties of inequalities, I want you to focus on multiplication and division. Okay, so this one is very important. So we base our property from A less than or equal to B. So it can be greater than or equal to also. But we have three numbers A, B, C. And first, for start, we have A less than or equal to B. Now, adding a number to inequalities does not change the inequality. If you add C on both sides of the inequality stays the same. A plus B, A plus C less than B plus C. So for example, let's say A is, let me use negative numbers so that we'll see the difference. So let's say A is negative 4, B is negative 2. Let's say I added 2 on both sides. So if I add 2, negative 4 plus 2 is less than negative 2 plus 2, which is in this case, negative 2 is less than 0, again, which is true. So adding number doesn't change the inequality. It stays the same. Okay. Now the second one is subtracting number. So let's say I have 2 is less than 4. I'm using 2 and 4. And I'm taking away 2. So minus 2 here, minus 2 here. Again, I have 0 is less than 2. Again, subtracting number doesn't change the inequality. Still less than. So when you subtract number and add number, it doesn't change the inequality. So this 2 does not change the inequality. So you can add numbers on both sides of the inequality and the inequality still stays the same. Now, but for multiplication, it will be different. For multiplication, it will be different. If you multiply by a positive number, the inequality stays the same. When you multiply by a number greater than 0, it says we have two conditions if you see here. If C is greater than 0, that means if C is positive, the inequality stays the same. It will be still less than or equal to. But if C is negative, the inequality will switch. Okay, so less than becomes greater than becomes less than. So let me show you with examples. So let's say I have again 2 and 4. 2 is less than or equal to 4. That's true. Now let's say I multiply both sides by negative 2. So let's multiply by negative 2. So negative 2 here times 2 and 4 times negative 2 again. So negative 2 times 2 is negative 4. 4 times negative 2 is negative 8. Now if you compare the two, negative 4 is greater than negative 8. It's not less than now. You switch the inequality. So it becomes greater than or equal to. So when you multiply and both sides of the inequality by a negative number, the inequality switches. Or for division, the same thing. if you divide both sides of the inequality by a negative number, it will switch. For example, again, 2 less than or equal to 4. Let's divide by 2. So if I divide by 2 here, oh sorry, by negative 2. Divide by negative 2. So this becomes negative 1. This becomes negative 2. Now, negative 1 is greater than or equal to negative 2. Now, switch. So keep this in mind. Just remember, if you multiply or divide by a negative number, the sense of the inequality reverse. Less than becomes greater than becomes less than. Otherwise, everything you do for inequality, you do for inequalities. It's the same. When you solve equation, adding number on both sides of the equation doesn't change the equation. The same applies here. Subtracting doesn't change. Multiplying by positive number doesn't change. Dividing by positive number doesn't change. So if you see this two, it doesn't change the inequality. But multiplying by negative and dividing by negative changes the inequality. So the sense of the inequality will be reversed. Greater than becomes less than becomes greater than. We saw that with this example. Do you guys have any question on this properties of inequality? Now let me add one property. If A is greater than B, then if you switch B and A, B is less than A. Okay, so sometimes you can switch the place of the two expressions A and B, and when you switch the places, you have to switch the inequality. For example, after solving an equation, let's say I found 7 is greater than X. But usually we write X, we compare X to 7 rather than 7 to X. So I can switch the places and I can say X is, now I switch the inequality, less than 7. Okay, that's basically what I mean by the last property. So when you solve problems and if you get something like 7 is greater than X, so it means X is less than 7. You switch the places and you switch the inequality. So 3 conditions you switch inequalities. The first one is when you multiply by a negative number. The second one is when you divide by a negative number. The third one is when you switch the inequalities. I mean the expressions. When you switch the expression on the right and move it to the left, you have to switch the inequality as well. Okay. Now let's go to our first example. So solving equation. So that's basically our objective, solving inequalities. So first I have one-step equations, then I have two-step equations, then we'll do multi-step equations. Okay. Now, if you see the first 4 examples, they are simple one-step inequalities. To solve inequalities, just assume they are like equations. The only time you will change the inequality is when you divide and multiply by negative number. Otherwise, it will stay the same. Okay, now if you see the first one, it is like x plus 4 equals 1. So to solve this, I have to undo addition. So I have to subtract 4 from both sides. That means x is greater than or equal to, it's just greater than. We don't have equal to. 1 minus 4 is negative 2. That's it. It's just one-step equation. Very simple. Okay. You do the same for the second one. So this is subtraction. To undo subtraction, we do addition. You add 6, and x becomes less than 15. So 9 plus 6 is 15. Okay. Now I want you to try the next 2 equations, and I want you to pay attention to dividing or multiplying by negative. So if you see negative, you switch the sign. Otherwise, it will stay the same. If you are multiplying by positive or dividing by positive, it doesn't change the inequality. Only when you multiply or divide by negative. Okay, now try the 2 and write your answer on the chat. What would be x over 2 greater than 9? Or negative 4x is greater than 20? Excellent, Jasmine. these are one-step equations. Just undo whatever operation you have in the problem. If you have division, you do multiplication. Okay, excellent, Jasmine and Diana. And so you multiply by 2, both sides on this one. So that way 2 cancels out. So I have x greater than 18. Excellent. Now what about the last one? Excellent, Jasmine and Hugo. Anyone with different answer? Still, just even if you have the same answer, please type on the chat. Excellent, Norma. Excellent, Diana. So you guys got this already. So all you have to do is just divide by -4. When you divide by negative, you have to switch the inequality because we are dividing by negative number. So this greater than becomes less than. I have x here. 28 divided by 4 is 7, and it is -7. Positive divided by negative is negative. Excellent. Excellent. Now let's see two-step equation. If you see the next equation, we have addition by 6, multiplication by -2. So I have to undo addition first. I have to take away 6 first here. So I have -2x less than 20 minus 6 is sorry, 14, just 14. Now I have to divide by -2 because it's -2 times x. So when you divide by negative, you switch the sign. So I have x and I have -7. I'm not going to use less than now. I have to switch it and I have to use greater than. That's basically the only difference from solving equation. Otherwise, it's exactly like solving linear equation. Okay, so the only time you switch the inequality is when you multiply or divide by a negative number. Okay, so now try the last example here on this slide, and after that we'll see multi-step equations. Everyone try the next one. Says 3 minus x is less than 1. 3 minus x is less than 1. Greater than 2. Good. Excellent, normal. Is there anyone with different answer from x? Okay, write down your answer. Okay, Diana has x greater than -1. Okay, now let's do this problem. So it is a two-step equation again. So you have to undo addition by 3. So I have to take away 3 here. So -x here, it is less than -2. 1 minus 3 is -2. So technically in front of x we have 1. So you have to divide by -1 both sides. Divide by -1. That way you have x. Now we divided by negative, so we switch the inequality and becomes x greater than 2. Okay. Next, we'll see multi-step equations. Okay, so multi-step equations or equations on both sides of the equation. So okay, guys, sorry about the babies is fine. So you distribute the 6 over x minus 5. So you have 6x minus 5 times 3 is 30 greater than or equal to 10 plus x. Then combine the variables, so I can move the x to the left. So just move the x to the left. Adding, subtracting doesn't change the inequality. So I have 5x minus 30 greater than or equal to 10. So this is a two-step equation. So you have to undo subtraction, add 30 on both sides. So you have 5x greater than or equal to 10 plus 30 is 40. Then you have to undo multiplication. So it's just one step equation now. You have to divide by 5. So we are dividing by positive number. So it doesn't change the inequality. So it will be still greater than or equal to 8. So 40 divided by 5 is 8. So the same thing, the same principle, like solving linear equation. Okay? So I'll do one more example, and I'll give you time to work on 4 examples in the next slide. Then we'll continue to the next topic. So the next example, the same way you distribute 3. So you have 3 minus 2 times 6. 2 times 3 is 6. So I have 6x greater than or equal to 1 minus 4x. So we can move the 6x to the right plus 6x. Usually I move the smallest number to the other side. So this cancels out. I have 3 greater than or equal to 1 plus 6 minus 4 is 2x. So I have now positive. That way, dividing by negative will not be a problem. Sometimes it is tricky when you divide by negative. So I will take away 1. So you can do it the other way around. You can add 4x on both sides and you get 3 minus 2x. That way you can have the same solution. So you have 3 greater than or equal to, 3 minus 1 is 2. So you have 2 greater than or equal to 2x. So divide by 2. I'm dividing by positive. 1 is greater than or equal to x. Now, if I want to write x in front, I have to say x is less than or equal to 1. So you have to switch the inequality now. So the third case, you have to switch the inequality when you switch the place of the two expressions. So I brought x in front to the left. So I have to switch the inequality to less than or equal to 1. Okay. So now I will give you 6 minutes. So right now it is 6:29. So we'll finish the next 4 questions at 6:30 and we'll talk about it. Okay? Here we go. So these are the 4 questions I want you to try. A, B, C, and D. Work on them for the next 6 minutes. It doesn't take more than 4 or 5 minutes. These are simple inequalities. Okay, so it's like solving linear equation basically. The only difference is when you multiply or divide by a negative number, you have to switch the inequality. Okay, now start working on these problems and Once you finish, type the answer on the chat. X greater than 2. Okay. Okay, guys, write your answers. We have actually 3 minutes. This is for you to practice. X greater than 6. Norma, check your seed for the sign. Then we have X less than 2. Very good. Less than 5. Negative 7. Okay, guys, we have 1 more minute. So for these problems, I'll give you just the answers. If you want me to do one of the questions, please let me know. Just write on the chat, do one of those 4 questions. T is less than 8. So I saw a very common mistake, that is when you divide by a positive number, please do not switch the inequality. Okay, some of you still switch the inequality when you divide by a positive number. You don't have to switch the inequality if you divide by a positive number. Only you do that when you divide by a negative number. Okay, so it is time. Let me give you the answers. So this one, -3 and -3, you will have 2x less than 4. So you divide by 2, which is positive number. X stays less than 2. Okay, do not switch the inequality. This one I have to move the 5 to the right and the x to the left, minus x. So x 2x minus x is greater than 5. Again, do not switch this, it stays the same. Number 3 here, 10x 4x, 10x plus 4x, so just 4, less than, this is 16, and plus 12x. Okay, so if I move this to the left, I have to subtract 4 also. That means negative 2x less than 16 minus 4 is 12. So I have to divide by negative now. I have to switch the inequality. So a negative, this is when you switch the inequality. Okay, see, you have to switch the inequality. For this one, I have to move this 2x to the left. I have to add 7. I'm doing 2 steps at the same time. So this one would be 2x greater than, this would be 8, 7, that's 16. Divide by 2. I'm dividing by positive. Please do not change the inequality if you are dividing by positive. So it will be x greater than or equal to a. Okay, so those are the solutions. Yep. Don't switch the last one. So because we are dividing by positive too. If you divide by positive, do not switch the inequality. You switch only when you divide or multiply by negative number. So keep that in mind. Okay. Read to B. Oh, okay. So B, very quickly. I know I so let me remove this. For B, I can move the x to the left. So B is simple. Okay, just subtract x from both sides. Minus x minus x. That gives you x minus 5 greater than 0. X minus x is 0. Okay, then plus 5 on both sides. Plus 5 on both sides. So x is greater than 5. That's how we get x greater than 5. Any questions so far? Okay, good. Now let's go to one application problem. So this is a common problem. It says a car rent for 30 per day. So there is a $30 fee on the car. Okay, so let's say that I have a $30 fee. And in addition, plus 23 cents per mile. So each mile you drive will cost you 23 cents. Let's say we don't know the mileage, so the mileage will be X, the unknown. So 23 cents times X amount of mileage will give you additional cost. Okay, so you are on a daily budget of $76. So right now you have $76. What mileage will allow you to stay within your budget? Stay within means it cannot be greater than that number. So it should be less than or equal to 76. So you can spend up to $76. That's the equation. Can you guys see how I changed the sentence into inequality? So the first cost is $30. So when you go, you rent the car for $30. Then for each mileage you drive, you will pay $23. So we don't know the mileage. So it will be x 23, 0.23 times x because it is cent. Cent is 1 over 100. Cent is 1 over 100. So 23 divided by 100 is 0.23. Okay. Now let's solve this. So you subtract by both sides minus 30 on both sides. So you'll have 0.23x is less than or equal to 46. Now we have to divide by 0.23 both sides, 0.23. So x is less than or equal to, divide this to 46 divided by 0.23. It's about 200. So you can drive up to 200 mileage. After that, you'll be out of budget. So you can't cover the cost. So this is 200 mileage. So when you rent, you know you can drive up to 200 mileage. Okay? Does it make sense? So this is one of the application problems. So you have different application problems in inequality. So you'll encounter them when you do your homework. So if you have any question, if you don't understand something, just check the exams on the book, or you can just ask me, send it, and I can talk to you. Okay, next we have the next topic, which is solving word problems. So we are going to look at some strategies to solve word problems, or things you have to know to solve word problems. So we are going to develop and apply general strategies for solving word problems. So this is a general strategy. So for everyone, that you can use different strategies, but generally you have to know some things like what is unknown, what is given, how do I figure out the equation, the overall general equation, and how do you find equations which relate to different variables or to unknowns. Then how do you solve it? So with that, the vocabulary for this general procedure for solving word problem, the first thing is figure out what is given. Okay? What is given? It says Gus, but G stands for given. So you have to notate all the given in the problem. So you have to take out what is given. You have to figure out what is unknown. So what is unknown? You have to ask the question, what are we looking for? What are we looking for? Or what are you looking for in this problem? What are you going to answer from this problem? Okay, so that gives you what is unknown. So you have to assign a variable for the unknown. So the question is, what are you looking for? And with that, because it is unknown, it will take a variable. The next one is equation. Identify or construct an equation from the problem. So the problem will lay out the equation. So it will tell you two different expressions are equal. That is your equation. Or it will give you something is total. That means you are adding two or three different things or four different things. So that is also an equation. If I say, for example, in two classes, I have 400 students or 200 students, I mean in class A plus B, I have 200. So that's also an equation. Okay. So the next one is substitute the given quantity into the equation. So there are two kind of equations you get. One is the general equation, like a total will give you a total. The second one is an equation which relate two different unknowns. So if you have multiple unknowns, you have an equation which relate the two unknowns. For example, if you are given a triangle or a rectangle and you are given the length and width, and you should be given an equation which relate the length and width. So that you can substitute that into the general equation. The general equation can be area, or it can be perimeter, something like that. Okay, so substitute, finally solve. So you have a linear equation, you solve it. Now for unknowns, you can use x and y to assign a variable. Usually commonly people use x and y, but it is very important if you use something which is meaningful. For example, if I say distance 1, you can use d1 to represent the distance. Distance 2, you can use d2, so that when you solve the problem, you know exactly what d1 means rather than what is x, what is y. So sometimes the students solve the problem and they will mix up the variables. So when you define your variable, you have to be more clear, or you have to list out why you are assigning that variable. So if you say a, you have, after solving the problem, you should know what is a, what is b, what is x, what is y. So for that reason, I'm going to use a little bit different variables so that we are not going to be confused with the variables at the end of the solution. Once you solve the problem, there is a strategy to assign a variables which clearly designate the unknown. Okay, let me do that problems and I will explain it while I'm doing the problems. Okay, we have one example here. A high school athletic association separates its school into 2 divisions. So we have 2 divisions. Together, Division 1 and Division 2 have a total of 332 schools. So we are given something. Division 1 plus Division 2 is 32. So the first thing we do is, let me finish the sentence. There are about 5.5 times as many schools in Division 1 than Division 2. So Division 1 is 5 times 5 times Division 2. So how many schools are in each division? So the unknowns are the divisions, the number of schools in the division. So first, let me list out what is given. Let me move this a little bit up so that we can have time. Okay, so here is the strategy. So it says first you have to figure out what is given. So what is given is total number of schools, okay, on both Division 1 and Division 2, which are 332. What is unknown are the number of schools in Division 1 and Division 2. Unknown. So the number of schools in Division 1 and Division 2. So we have to assign variables. So variables here. You can say X is Division 1, Y is Division 2. But I can also use D1 is Division 1 and D2 for Division 2. That way, I will not be confused when I solve the problem, okay? Now, the first equation, so you have tried equation. The first equation we have is Division 1. So let me write on the left-hand side so that I can use the space. Division 1 plus Division 2 is 332. So the number of schools in Division 1 plus the number of schools in Division 2 are 332. That's the first equation. The next equation says there are 5.5 times as many schools in Division 1. So Division 1 is 5.5 times Division 2. Okay, so this is equation. Find the equation. And next it says substitute. So what it means is, we know Division 1 in terms of Division 2. So I'll take this and I'll substitute that into Division 1 here. So write the equation by substituting Division 1 by 5.5 Division 2 D2 plus D2. So that's 5.5 D1 is basically Division 2 is Division 1 equals the 332. So the next step says solve this. So we can easily solve this equation. So combine the two. 5.5 plus 1 is 6.5. D2 equals 3, 3, 2. So we divide both sides by 6.5. So divide by 6.5, divide this by 6.5. So division 2 is divide 332 divided by 6.5 is 51. So there are 51 schools in division 2. Now to find division 1, we know division 1 is 5.5 times division 2. So division 1 equals 5.5 times division 2, which is 51 in this case. Just substitute back. So division 1 equals multiply 50.51 by 5.5, which gives you 280.9. So we round it to 281 because the schools are whole numbers. So the number of schools should be a whole number. Okay. So what this means is in division 1 we have 281 schools. In division 2 we have 51 schools. That's it. That's basically what this means. Any question on how we strategize to figure out what is given, find out what is unknown, assign a variable for the unknown, write the equations. There are two equations. One is the overall general equation. It tells you the two divisions have 332 schools. Then the second equation relates the division 1 and division 2, which says division 1 is 5.5 times division 2. Then substitute, S stands for substitute, and solve the equation. And finally, because we know division 2, we can easily figure out division 1. If you have any question, write on the chat. I think people are writing. Let me wait. Then we'll move to the next example. Yeah, always. D1 is 1, D1. Yeah, yes, no. Okay, good, Avi. So I was waiting for you. Okay, let's move to the next one. So when it says D1, it's technically 1 D1. So 5.5 D1 plus 1 D1 is 6.5 D1. Okay, now let's move to the next question. So the next question here has I'll represent it pictorially and we can discuss about it. Okay, now it says 2 low-flying missiles are launched from the same location at sea level and sent in opposite direction. So let's say this is the starting point. One missile is going this direction, and let's say the missile is right here. Okay, the other one is going in this direction, and let's say the missile is somewhere. Sorry about my drawing. Just assume this is the second missile. Okay, now the question says after 5 seconds. So T is 5 seconds. T is 5 given the time. The distance between the two will be 33,000 feet. So here to here, the overall distance becomes 33,000. So we have two distances. One is the distance for the fastest missile, and the other one is the distance for the slowest missile. So let me use different color to. So let's say this is the fastest. Oh, sorry. I was supposed to use different color. So let's say this is the fastest because it travels a little bit longer, and the second one is the slowest. Now here is the strategy. So we have D1 and D2. So distance 1 for the fastest and distance 2 for the slowest. So this is D1, this is D2. Okay, now there is something given. So the missiles are traveling, so the fastest missile is 600 feet per second faster than the slowest missile. So one is 600 feet per second faster than the second. Okay, now we know distance is velocity times time. I don't know if you guys know this, but the distance is the velocity or the speed times time. Speed times time, basically. So let's say the speed of the fastest one is the slowest one is v. So let's v is slowest speed. Okay. So I can write d1 as that's the fastest one. V plus 600 is the speed because it is the fastest one is 600 more than the slowest one. This times the time, which is 5 seconds. Distance one is v plus 600 times 5. So this one is v plus 600 times 5 or 5 times that. Now let's see distance 2. Distance 2 is for the slowest missile. So the volume, the speed is v. So it is v times 5. V times t, which is v times 5 or 5v. So let me write it 5v because the time is 5. It's given. So this one distance 2 is 5v. Okay. Now we know the two are separated by 33,000 feet. So we know d1 plus d2 is 33,000. And we have the equation for d1, we have the equation for d2. So d1 is 5 times the speed of the slowest. V represent the speed of the slowest missile plus 600 plus d2 is 5 times the speed of the slowest one equals 33,000. So we can easily figure out the speed of the slowest missile. So, but we are asked for the speed of the fastest. What is the speed of the fastest missile? So we will answer it by adding 600. Okay. Now let's solve this. Distribute the 5. So 5 times v is 5v plus 5 times 600 is 3,000 plus 5v equals 33,000. So 5v plus 5v is 10v plus 3,000 equals 33,000. So we have to subtract 3,000 from both sides, minus 3,000 from both sides. So 10v, remember v is the speed of the slowest missile, equals 30,000. Okay, so 33 minus 3,000 is 30,000. So divide by 10 both sides. Divide by 10. That means v is 3,000. 30,000 divided by 10. You just cancel the 1 0. Now this is the speed of the slower missile. So the faster will be v2 equals 3,000 plus 600. So the fastest speed is 3,600 feet per second. And we are asked for the fastest one. So it's just solving linear equation. But understanding the problem and coming up with the equation is the most important step. So what is given is distance 1 plus distance 2, because they're separated by 33,000. It is like the general equation. So you have to figure out what is distance 1, what is distance 2. So distance 1 is the speed of the fastest, which is the speed of the slowest missile plus 600 times 5, because the time 5 is given. For both of them, the time is 5. They were fired at the same time from the same location. They were launched from the same location. Okay. Any question on this example? Does the graph helps? I hope I didn't make it more complex. So the graph should give you some insight into the problem. So it will clearly shows you the two are going in opposite direction, and the distance between the two becomes 33,000 feet when the time is 3 seconds. So you have distance 1 traveled by the fastest missile, distance 2 traveled by the slowest missile. And if you say v is the slowest speed, the fastest speed will be v plus 600 because it's 600 more. And we know distance 1 is time times the speed, which is 5 times v plus 600. The second distance will be 5 times the speed of the slowest missile, v. After that, substitute d1 and d2 into the equation and solve for v. And you have to know v is the slowest distance. So to find the fastest distance, we have to add 600, the faster distance. And v is the slower. The faster distance will be 3,000 plus 600, which is 3,600. Okay. Now I'll show you another example, which is a little bit more complex than this. It's a chemistry problem. If you go to chemistry or pharmacy, you'll see problems like this. It is mixing a solution. I'm going to use pictures to represent the problem so that you will understand it better. Now, the problem says a pharmacist wished to mix a solution of 2% minoxidil. I don't know exactly, minoxidil or minoxidil. So 2% of minoxidil. She has on hand 100 milliliter of 1% solution. So she has 100 milliliter of 1% solution and wishes to add 4% solution to obtain a desired 2% solution. So from 1% solution, she wants to make it a 2% solution. But at hand, she has a 4% solution. The question is, how much of the 4% solution should she add? Okay, now let's see here. First, I have this bucket which contains 100 milliliter of, so this is in milliliter, of 1% solution. That's what she has. And she wants to add a 4% solution, which is unknown. So we know the percentage, which is 4%. So this is the unknown. The volume of the second bucket is unknown. And this should give you the third one, which is 2% solution. Now, we know the volume. When you add 100 plus x, it will be 100 plus x. So still unknown, but it will be 100 plus x. Now, we know the amount of minoxidil in the first bucket, which is 1% of 100. So 1% times 100 plus the amount of minoxidil in the second bucket is 4% of x equals 2% of the total. So the amount of the minoxidil in the last solution is 2% of the total volume, which is 100 plus x. Okay. Now everything is in percent. I can cancel out the percent. So when you cancel out the percent, you'll have 100 times 1. So, or 1 times 100. So you have 100 plus 4 times x, which is 4x. So cancel the percent, okay? From each one of them. Equals 2 times 100 plus x. Remember, x is the volume of the 4% solution. Okay, so we have a linear equation. So distribute the 2 here. And you have 100 plus 4x equals 2 times 100 is 200 plus 2 times x is 2x. So we solved this equation. So I will move the 2x to the left. first, minus 2x. So 100 plus 2x here. 4 minus 2 is 2x equals 200 minus 100 minus 100. So this gives you 2x equals 100. 200 minus 100 is 100. So divide by 2. Divide by 2. X is 100 divided by 2, which is 50 milliliter. So she needed 50 milliliter of 4% solution to mix a 150 milliliter of 2% solution. Okay, so this is a very common problem in chemistry labs. You will be given some reaction and you are asked to make let's say a 2% or a 5% solution of, let's say, hydrochloric acid or something like that. So you have to know how much volume of concentrated solution you are going to add, or how much volume of, let's say you have a 10% solution and you want to reduce it to 5% and something like that. Okay, so this is a very common problem when you go to chemistry lab. Okay, so I hope this is described very accurately with the picture, so that you know how to change the problem into, the word problem into an equation. Any question on this example? Okay. Yeah. So usually word problems, if you manage to represent them in some kind of picture, or in some way you understand it, it can be represented in something different. But this physically represents the two buckets you have, and when you combine, you have a total bigger bucket, so that you know exactly you are combining solutions, and you know one plus the other gives you the total. That's how we solve problems like this. Okay, the next question you have to try. So we have 13 minutes. I'll give you 6 minutes to try the problem. Then the next 4 minutes we talk about it. So someone is writing a question. So let me wait for that. Wait 1 minute. Oh, okay. Oh, okay. We'll talk about that. That's a specific question. Okay, now this question used 6 minutes. So we have we are right now at 7:08. You need 5 minutes, I think. At 7. Okay, 5 minutes. 7:08 right now. 7:13. We'll come back and we'll discuss about the question, and that'll be the end of the lesson. So everyone start this problem. It says rectangular plate is to be the base for a circuit board. Its length is 2 inches more than the width. So remember this, it's equation. The length is 2 inches more than the width, and it has a perimeter of 36 inches. Find the dimensions, find the length, and find the width. So this is what you have to report. So the length and the width. Okay. Okay, guys, when you finish, type the answer on the chat. We have 3 minutes. Okay? Let me give you that pictorial representation. So, oh, so that's too much. So this is the length. This is the width, and the perimeter is 36. So if you forget, this is the formula for perimeter. Twice the length plus twice the width equals the perimeter. P represents the perimeter. Okay, guys, write your answers. It's almost time. So 9, is that for length or width? So we have two parameters. So you have to find 2 dimensions, the length and the width. They are equal. Okay, so you found the width and the length are equal, but if you see on the sentence, it says the length is 2 more than the width. So let me go over the problem. So it says the length is 2 more than the width. Okay, so that's basically here. 2 more than the width. So I will substitute the L by the W plus 2. So 2 times, that is for L, plus 2W equals P, which is 36. So the perimeter is 36. Okay, now we can easily solve the width. So distribute the 2. So you have 2W plus 2 times 2 is 4, plus 2 again, W equals 36. Combine the 2 here. 2 plus 2 is 4, plus 4 equals 36. So minus 4 from both sides. That means 4W equals 36 minus 4 is 32. Divide by 4. Divide by 4. W equals 8. Now we know W, we can easily find the length, because the length is 2 more than this. The length is W plus 2, which is 8 plus 2, which equals 10. Now the dimensions are inch, okay? It's given in inch. So it's very important to write the dimensions also. So the length is 10 inch and the width is 8 inch. Any question? Any question? Type on the chat if you have any question. Okay guys, so this is the lesson for today. This Thursday will not have a class, so I'm going to take a day off. Because of the pandemic, we have a furlough day. We have to take a day off. So this Thursday, we are not going to have a class. If you have any question, stay behind, type on the chat. We can discuss about it. Otherwise, this is the lesson for today, and I'll see you guys next Tuesday. We have quiz 5. Every Sunday you have a quiz, okay? It's already posted. If you don't see it, let me know, okay? So every Sunday you have quizzes. So we'll cover from, so it will include 3.5, yes, 3.5 up to 4.4, what we just studied. 3.5, 4.1, 4.2, 4.3, and 4.4. So that would be about 20 questions, so it will be fine. Okay? Okay. See you guys next Tuesday.